to present here. So my topic is today is for the this is basically for the data side. It's a cloud native data engineering as a foundation of AI innovation, AI driven innovation. So do I need to introduce myself, go detail, or like I can go from here? Raziullah Khan. Uh, I'm the technical architect and software service company, and currently working with multiple customers from the healthcare side, healthcare provider side. So, and I'm located in the Columbus, Ohio, in US. So, I'm going to present today the cloud native data engineering as a foundation of for AI-driven innovation. This is my topic today. So, agenda there are uh, I'm going to cover data fundamentals and AI imperative, Medellin architecture, challenge in modern data lakes, deep dive, like basically bronze, silver, and gold layer, and in this pattern and the real-time streaming. And I'm going to cover the security, quality, and the governance and the tech stacks, basically, along with the use cases. All right. So data of fundamentals and the AI and the AI imperative. What is data? So data is anything like basically we can by the definition if I go, it's basically raw fact collect from the systems, people, device, anything which we are doing that we can collect the data. So data is like there are three types of data basically available right now. One is structured, semi-structured, and unstructured. So structured data is basically the I would say like it's a relational database. Relational data includes a table, rows, and columns like normal SQL database. SQL database. Semi-structured is we can say JSON, XML, Avro, or Parquet file is a semi-structure. Unstructured is basically anything which is text, image, or PDF, audio, video. The five V's of big data: volume, velocity, variety, v- veracity, and the value. So, value means like we have data in the TBs, terabyte, petabytes on the daily, and velocity is the real time and the batch stream. The data which is coming, and variety is basically structured data or unstructured data. Veracity is basically quality and the trustworthy. How good data is that? How good that data quality. Value is driving decision and prediction. So this will be used for AI ML use cases. That is basically the value. The challenge is why data lake failed AI teams. So data storms and data lakes organization often end up with this no schema enforcement. If we are not using the schema enforcement, so raw data lands with no structure that can I mean that will the AI model cannot consume it's not reliable. No data lineage. What is the data usage? I mean, if we did not define the data usage, I mean, nobody knows data where the data come from and who is using that and why using that. The data lineage is very important. Siloed system, data is scattered across the multiple systems. No unified access layer. There's no we defined access. No, I mean no layer we define. Duplicate and dirty data. Inconsistent source produce the the produce the duplicates and nulls, wrong types of data. Lack of governance, like in healthcare, basically HIPAA and GDPR compliance is there. So lack of governance, no future use. Like we cannot use the data in the future. That will be failed. Medellin architecture. So all the data is, if you talk about most of the companies, I'm talking about the corporate side. So we use the architecture called the Medellin architecture. So a three-tier data architecture that organize the data into a distance quality layer, each presenting increased readiness for analytics and AI applications. So one is, if you see here, the data source. Data source is basically maybe API. We are fetching the data by using the API. We're fetching the data by from the database or streams of file. Bronze layer is basically raw layer th- that is called source identical data. We call as a raw landing zone. A silver layer is cleans and enriched. Like the second layer is we remove the deduplication, we remove the duplicate data, or we are if you want to do the sorting, that is sort data. uh, that's going to be the silver layer, and the gold layer is basically data is ready for the analytics, for the reporting or AI ML analytics. That data is basically called gold layer. Data quality, each layer progressively improves the quality. So data quality is improving from bronze to silver, silver to gold. Scalability, cloud native design, horizontal without re-architecture. There is no need to re-architecture. We can scale the data as much we can. AI ready, gold layer provides the feature stores and curated data sets for ML. And this governance is basically it will show the full lineage where data is using for the audit trail and what is the uses of the data. Now I'm going to the deep dive of the each layer. Basically, bronze layer, raw landing layer. Bronze layer is immutable landing zone for all the raw data entering to your platform. It preserves the original source, fidelity, enablement, complemented audit trails, and the full historical replay. If you see the characteristics, so basically storage format, transformation, what is the data quality, what is the schema of that, what is the retention policy of the data, whether we did the partitioning clustering or not. So that is the characteristics. If you see this storage, so original native format, why it is matter? Preserve the source fidelity. Example is basically for the storage, it's going to be CSV, JSON, or Parquet file. Transformation, uh, minimal type casting only, and speed of ingestion, how fast and how fast we can do the data ingestion, basically the velocity of the ingestion. And example is basically data parsing only. Data quality, not validated it, raw capture baseline, duplicate may exit in the data quality. Schema, source and schema, simplifies source, why this matter? It simplifies the source mapping. And example is original columns name. Retention, uh, retention description, immutable and the permanent. Why this matter? Complete audit trail and all historical records are there. That is example. Partitioning, we can do it a many way. So partitioning, we are using like ingestion data, ingestion date or time. We can also use that too. Why this matter? Inefficient time-based queries. And example is uh, date format. Silver layer. After bronze layer, we move to the silver layer. Silver layer is applied the business logic, perform deduplication, handle missing values, and join the data from multiple sources to create the enterprise-wide consistent data set for analytics. So key transformation. Uh, so what transformation we are doing from the bronze to silver is basically just noting down the key transformation. Remove duplicates, null values, apply business logic, domain rules. You can use the join, accurate the multiple source. For example, we have a 10 data sets and 10 data set having like a uh, almost like 100 tables, and we want to join the data. So we can write the join query by using SQL and fetch the data from 10 tables and drop into the gold layer. Enforce data type standard. So whatever the data types are there, so we can enforce it. We can make a changes from the bronze to silver layer. Create conform and shared dimension. So we can also here use the dimension and fact data warehouse concept here and validate the reference integrity. Data quality gates. So schema validation 100%. So and null checks we can do it 99.9%. Deduplication 98% can be done here, and referential integrity 97%, and the business rule we can pass 95%. Gold layer. This is the the top layer. Uh, Basically, that is AI ready and analytics for ML. We can choose the reporting here. The gold layer delivers aggregates curated data sets optimized by the BI dashboards, any BI tool, advanced analytics, and machine learning. The direct fuel for AI driven innovation. Analytics ready. Fully aggregates dates optimized for a BI tool, implement a star schema fact and dimension tables, supporting the complex analytics query with a low latency. Latency is very low. I mean, we can we can optimize the latency. ML feature store pre-computed feature and engineered dataset prepared for a machine learning, enable rapid model development with consistent and reusable features pipelines. Dimensional modeling. Star and the snowflake schema reduce the query complexity. Materialized view can create the materialized view to pre-aggregate. That will be always the response time. The performance time is very high, and the query is like a 10 to 30x performance gains. AI consumption layer serves real-time and the batch interface interference pipeline provides a cleaning training data sets, validation sets, and ground truth level for AI model development. Data ingestion pattern. So we have a data as a at the source end. We need to do the data ingestion by using the different pattern. So number one is we can do the uh, batch ingestion. So basically, by using the schedule ETL job or ELT jobs, we can route the file, the Parquet file, CSV file, JSON file to the bucket, and from the bucket data can ingest. Database snapshot also we can use. The best for data warehouse is daily report. Streamulation is basically there are different ways of streaming is available in the market. So Apache Kafka is one of the and Apache Kafka and we have a Kinesis basically for the AWS and even have sub-second latency pipeline. We can have a bash batch with the Spark streaming and the best of IoT and click stream fraud. CDC is basically change data capture. So there are multiple tools are available in the market, which is we can use a CDC. We can fetch in the data from source and do the data ingestion to the target, and that will be that is almost like a near to real time. Business impact on performance metrics. So, uh, data accuracy 92% improved post Medellin architecture. So that is a very good thing for by using the Medellin architecture. Faster insight is 60%. Cost reduction is 45%, and 3x query speeds with the smart partitioning and clustering. We can do that. And these are the metrics before and after Medellin architecture. So the query time is like 45 and it is in the minute. And if we use a Medellin architecture, it's go down to like almost like a zero. Same error rate is also improved. Data freshness and the onboarding is always a lot of improvement happen after the using the Medellin architecture. Governance and security. This is very important for any data platform. How you are going to govern and how you are going to manage the security. So this is the role-based access control. So that's a IAM rule. We can implement the IAM rule, and we can control the access by using the AD group or service account. Have a like limited access. We can do that. Data lineage, again, which I explained in my previous slide. So data lineage is basically end-to-end lineage tracking from the source system to gold layer. That can be auto-generated via Apache Atlas, and we have other tools, Colibra, a lot of tools available in the market that we can use that. Data quality SLA, automatic, automated anomaly detection, schema drift alerts, data freshness SLA, monitoring with a page duty integration. Encryption is again, this is very important. Data should be uh, encrypted at the REST AES 256 and the transit to TLS version 1.3, and secure key management by using the different KMS, AWS KMS, and the GCP or GCP KMS, Google Cloud platform. Regulatory compliances. So, talking, I mean, my main experience and this presentation is basically related to the healthcare. So we have a GDPR, HIPAA SOX compliance with the full audit logs, data cataloging, the business glossary and the data dictionary, and the asset metadata change via Colibra or Apache Atlas. Quality assurance framework, accuracy is 99.9, data freshness 98%, compliance 100%, completeness 94%. Validation gets automated prevention and the data testing and monitoring. So validation gets is schema validation rules. We can uh, and the business logic checks, anomaly detection alerts, cross-source reconciliation, data testing, unit test pipeline, integrated testing, regression testing on updates, data contract enforcement, monitoring real-time data quality dashboard, SLA breach alerting, incident response playbooks, and the root cause analysis tooling. Technology stack recommendation, data platform. These are um, this is the recommendation from my end based upon my experience and research. Data platform, Databricks, that is basically Delta Lake, and the Snowflake is also very good. Google BigQuery is there, and Azure Synapse Analytics. Orchestration tool, we should, I mean, Apache, the available option is Apache Airflow. This is very nice, perfect. Dexter, Accurate Azure Data Factory. Transformation, DBT, data build tool, Apache Spark is there, PySpark, SQL is there. Streaming, Apache Kafka, Kinesis, Azure, even Confluent platform. ML AI, ML Flow, Feature Stores, that is Databricks, SageMaker, AWS, Vertex AI, GCP. For the governance, Colibra is there, Apache Atlas, AWS Glue Data Cleaning, and Unity Catalogs. Industry use cases and the success stories. Healthcare patient risk and care analytics. Hospital network uses the Medallion, Medallion to unify the EHR labs and claim data to the gold layer. That's a power real time prediction model, which is 87% accuracy and reduce ICU readmission by 23%. Financial fraud detection can be fraud detection. The risk analysis by using this Medallion architecture can be helpful, and retail personalization and the inventory optimization. If you're using the Medallion architecture, that will be do that, and manufacturing productive maintenance and the quality. It's a less downtime. Events per day ingested like 10 billion and 98.0 improvement. Implementation roadmap start to scale. So this is the implementation roadmap which I created. So 1 to 3 months you can have a foundation that we can call phase one, phase two quality enrichment, which is like 4 to 6 months, and the 7 to 12 month like AI implement. Like it's 1 year of the roadmap which I created based upon my experience. Common challenges, how to solve them. Late arriving data. So implemented like watermarking and without a process. Use backfill strategy, event time processing. Schema evaluation, apply schema evaluation on the read on the brown side. Once data get injected. Cost overruns, partitioning. This is very important to save the cost. So we can choose a partitioning and clustering. Org assistant start the high visible use cases, demonstrate the ROI, return of investment in phase one, build the data culture and data lit literacy training and the self-service enablement, reduce the shadow IT. Uh, Data silos, federated ingestion and the centralized catalog. Uh, Skill gaps, upskill with the database academy or whatever platform you're using, we can get the learn from there. Best practices for the Mendelian excellence. Data first, um, think analytics enable teams to start working, start small scale, fast, automate the quality and the measure continuously. Measurement is required too. So these are the references which I use. That will be student or when you wanted to go and learn that. So these are the Medellin architecture Databricks provided. So I use that from there. And for the community as data engineering wiki is there. Apache Kafka, MLflow is there. So these are the links which I from where I learned. Thank you.